Okay, let's talk about rocks. And I know what you might be thinking. They're just rocks, the ground beneath our feet. But what if I told you they're the original inhabitants of our world? Seriously, they were here before the oceans, before the forests, even before the oxygen we're breathing right now. They've been here since the very beginning, and today we're going to dive into their incredible, untold story. And that's the key right there. Rocks aren't just the scenery in this story. They are the main characters. They're active participants and ancient storytellers, and their history is fundamentally our own. So let's start at the very beginning with what is probably the most important relationship in Earth's entire history, the coevolution of rock and life. Because, and this is wild to think about, without minerals, life as we know it just couldn't exist. No oxygen, no continents, no us. So where did it all come from? Well, before our solar system even existed, there was this massive cloud of dust from exploded stars. And that stardust, made of tiny mineral particles, was pulled together by gravity into bigger and bigger clumps, which eventually formed our planet. So in a very real sense, we are all made of stardust. But the young Earth was nothing like the blue marble we know today. You have to picture a glowing ball of fire, just a molten mass constantly getting slammed by meteorites. Geologists actually call this the Hadean era, named after Hades because it was, and I mean this quite literally, a mineral hell, a world with oceans of magma and almost no solid surface. The story of Earth is just, it's almost incomprehensibly long. Life itself took hundreds of millions of years just to show up. And you see that tiny, tiny sliver at the very end? Yeah, that's us. Our entire industrial society, everything that has so profoundly changed the planet, is just a flicker in geological time. Okay, so after all that fiery chaos of the Hadean era, Earth started to cool down, and a new, really dynamic partnership began. Life emerged. And it didn't just exist on the planet. It started to actively shape it, working together with the mineral world in this great coevolution. And one of the most transformative moments in that whole partnership was driven by tiny, microscopic bacteria. Get this, they started producing oxygen basically as a waste product. For over 1 billion years, the planet's rocks and oceans just soaked it all up. But once they couldn't hold any more, oxygen flooded the atmosphere, created the ozone layer, and paved the way for all complex life. Life literally terraformed its own planet. And the power of the microscopic world is still just immense. Today, a staggering 98% of all life in the oceans is plankton. A single liter of seawater can contain 10 times more of these little organisms than there are humans on the entire Earth. So, yeah, their impact is anything but small. So how can something so tiny have such a massive effect? Well, take a type of plankton called a coccolithophore. It builds these tiny mineral plates for itself. When billions and billions of them die, their little skeletons rain down onto the ocean floor. And over millions of years, all that sediment gets compressed into solid rock. And we're not talking about a small-scale thing here. You know the famous White Cliffs of Dover in England? Those are mountains built from the skeletons of countless microscopic creatures. It's an absolutely incredible testament to how life actively builds the geological world. And life didn't just build mountains in the sea, it also conquered the land. For most of Earth's history, the continents were just barren rock. The very first pioneers were lichens. These tiny, slow-growing organisms are total ecosystem engineers. They release these acids that dissolve rock, grain by grain, unlocking nutrients and creating the very first soil. They were literally preparing the ground for plants to follow. So for billions of years, this give and take between life and rock shaped our planet. But then, a new force emerged. A single species that would fundamentally change this ancient relationship, and at a speed the Earth had never, ever experienced before. You know, for most of human history, our relationship with the mineral world was one of coevolution. A rock was an extension of the hand, a tool for survival. Rocks gave us fire and became the canvas for our earliest art, our memories. But about 250 years ago, that all changed. With the Industrial Revolution, we stopped just using rocks and started consuming them for energy. We became an extractivist society. And this really is the core of our modern dilemma. We started to dig up and burn hundreds of millions of years of fossilized life, coal and oil, releasing all of that ancient carbon back into the atmosphere. To think that such a massive intervention wouldn't have profound consequences was, well, to put it mildly, it was pretty short-sighted. This new relationship hasn't just changed the atmosphere, it's changing the very geology of the planet. We are now creating a permanent physical layer in the Earth's crust. It's our own footprint, written in stone forever. Just think about concrete, the artificial rock of our civilization. In just the last 70 years, humanity has produced over 500 billion tons of this stuff. That is enough to cover every single square meter of the Earth, both land and sea, with a kilogram of concrete. That layer is going to be a permanent part of the geological record. We're even creating entirely new types of rock. Say hello to plastic lamerite. It's a bizarre hybrid that forms when plastic waste melts and fuses with natural stuff like sand and pebbles. And it's now being found on coastlines all over the world, a really disturbing and permanent geological signature of our age. And the researchers who study this stuff, they see it as way more than just a curiosity. For them, it's a clear symptom. It's a warning sign from the planet that our actions are having deep, lasting, and pretty unpredictable consequences on a geological scale. So, where does that leave us? For billions of years, the rocks have been telling this story of slow, collaborative change. And now, a brand new chapter is being written at a frantic pace. The real question is, are we listening to what the rocks are trying to tell us? You know, some people might think our modern world has elevated us above nature. But the truth is, our technological society is more dependent on geology than ever before. The lithium in our batteries, the copper in our walls, the rare earth elements in our phones. We are more deeply embedded in the mineral world than any of our ancestors ever were. Maybe the problem isn't that the Earth is silent, but that it just speaks way too slowly for us to hear. Its stories are told over millions of years. To understand our place in this story, we have to adjust our own perspective. We have to slow down and learn to read this ancient language. It's pretty clear we're no longer just living on the Earth. We are actively shaping it, for better or for worse. We've become a geological force. And that leaves us with a really profound question. What kind of story will our layer in the rock tell future generations? What kind of ancestors are we going to be?